All right, welcome back, guys. So remember yesterday how we talked about finding the summation of concrete examples? So, for example, I need to hit the pen. Thank you. From I is equal to 1 to 4 of I. Well, it's a concrete example because I can actually plug in my number 1, 2, 3, and 4. Today, we're going to take a look at finding the summations of things that are not concrete to manipulate them enough to turn them into a formula so that I can plug numbers in. Because I like formulas where I can plug in numbers, whereas finding summations of stuff that I don't have an upper or lower bound for. Okay, so my first summation formula is the summation from I is equal to 1 to n of c, where c is a constant. And what I'm going to do is I'm going to turn that into c times n. So basically when I take the summation of a constant over and 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 over again, it's like saying that constant times n. My second one is the summation from I is equal to 1 to n of I. And that's going to be n times n plus 1 divided by 2. Again, it looks like I'm taking easy looking things and making them scary, but we really won't be, I promise. It makes something kind of easy even easier. We just play around and manipulate it. My third one is the summation. Ooh, that's really bad. From I is equal to 1 to n of I squared is n times n plus 1 times 2n plus 1 divided by 6. And my last one, the summation from I is equal to 1 to n of I cubed is n squared times n plus 1 quantity squared divided by 4. Alright, let's put these bad boys into use. So, yesterday we also talked about how my lower bound, or my index, had to match whatever was in my summation. Well, if you notice, I have two different letters in there. I have I and N. So what I need to do is I need to take this summation so I can turn it into something that looks like with just N's to make my life easy. So to do that, I need to manipulate my summation so I can get stuff and plug it in and pull it out. So what I'm going to do is I'm going to take out a 1 over n squared because I'm dividing out that guy. I no longer want my fraction because I want to work with manipulating my i's. So I don't want my n in there. And since he's on the bottom, he's going to stay on the bottom. So I bring out a factor of 1. And when I do that, I am left with 4i plus 1. So I'm going to go ahead and replace my I now with my n times n plus 1 divided by 2. So off to the side I have my 1 over n squared. I still have the 4 there. And it's 4 times I, so I need to replace that with n times n, times n plus 1 over 2. Because only that has the 4 with it. And then plus, well, 1's a constant. And I said I take that constant value times n. And again, I promise this looks scary and you're like, ah! We will end up simplifying stuff and canceling things out and it'll make my life great and easy and it'll be like, oh, that makes more sense. So moving forward with simplifying, I am multiplying by 4 and dividing by 2. So I know I can cross those out and I am only going to end up multiplying by 2. I'm going to leave my 1 over n squared off to the side because I want to simplify inside before I multiply them in. Because then I got to make sure I do every single piece. And if I mess up and make a mistake, hopefully I can do basic addition and subtraction and then put in my division. So I'm going to multiply 2 in with my n, which gives me 2n. And I'm going to take that times n and n plus 1. So I get 2n squared plus 2n. 1 times n gives me n. Then I have 1 over n squared times 2n squared plus 3n. Now that that's simplified into something easier, I'm going to throw that division back in. And essentially it's like saying both pieces have a divided by n squared. N squared over n squared cancels and gives me 2. Plus, I have 1 more n on the bottom. So I have 2 plus 3n. I was looking for my calculator. Because you want to grab one of those. So if you don't have a calculator, please pause video and go get it. Ta-da! Handwritten calculator. And the reason we like doing this formula is because it allows me to find the summation of it allows me to find the summation of values up until then. So for example, if I let n equal 10, it will find the summation of my values from 1 to 10 by just plugging in n in this last stage. So that'll be 2, maybe, plus 3 over 10. And in my handy dandy calculator, I have 2 plus 3 divided by 10. Which gives me 2.3. And then if I let it be 100, I get 2 plus 3 over 100, which is 2.03. When I let it be 1,000, there you go. Sorry, none of zeros. I get 2 plus 3, 1, 2, 3. I get 2.003. Yay! I just found the summation of 1,000 numbers by plugging in 1, which is a lot easier than yesterday. Because if you think about it, do you really want to find the summation of 1,000 numbers? From 1 to 1,000. Okay, moving forward, let's go ahead and try this next example. So I'm going to start again by factoring out my 1 over n squared, which leaves me with I plus 1. And I know that I is equal to n times n plus 1 divided by 2 plus 1 times n. Because it's my 1 times my constant, in this case 1 times my n value. So I get 1 over n squared times n squared plus n divided by 2. This time I didn't have any fun cancellation going on. Well, again, I want to combine my terms before I multiply in that n squared, or excuse me, 1 over n squared, because it deals with issues and blah, 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 blah. So what I want to do is I want to get this guy to add with this thing. Well, this brings in my rules of fractions. Technically, right now, he's divided by 1, so I'm going to turn him into 2 over 2. Which gives me 1 over n squared times n squared plus n plus 2n all over 2, which allows me to do that adding. So 1 over n squared times n squared plus 3n divided by 2. At this point, I can go ahead and say goodbye to your n squared. He's over here in the denominator. We know that everything is going to cancel. Excuse me, we know that both terms have things that are canceled, so I'm left with 1 over 2 plus 3 over 2n. And again, we're going to let n equal 10, n equal 100, and n equal 1,000. Which gives me 0.65. 0.515. And 0.5015. Again, my lower bound and my variable in my summation match. Yes, I know it's not an I, but it's the same process. So we're going to start by taking out the 1 over n squared. And I'm left with 5. Oops, see, I'm so used to writing i's. 5j plus 4. And we're going to go ahead and replace those guys with 5 times, j is the same thing as just having an I. So that's n times n plus 1 over 2. Plus 4 times n, because it's my constant times n. So 1 over n squared times 5n squared plus 5n over 2 plus 4n. And again, I want to make that guy divided by 2, so when I do that, I have to multiply him by 2, so he turns into an 8. Which gives me 1 over n squared times 5n squared. 5 plus 8 gives me 13. Divided by 2. So he gets to come in here. So I get 5 over 2 plus 13 over 2. So when I let n equal 10, I get 3.15. Now let n equal 100. Get 2.565. And then it equals 1,000. I get 2.5065. So not terrible. Okay, these next two have this a little bit of a different part. It's got something we're not used to seeing. At least we've seen, but haven't seen in a while. Bum, bum, bum. My magical limit. So this only adds one extra step. So I'm going to start the same way. I'm going to take out my 1 over n squared. And I technically still have my limit there, but I'm not going to write him every time because we know in the back of our head he's there. I'm going to run out of room if I do it. Which leaves me with just 25i. And when I rewrite that, 1 over n squared times 25 times my I is, oops, back up a second. N times n plus 1 over 2. I don't have any other constants to add to it. Woohoo! Finally. So I have 1 over n squared times 25 n squared plus 25 over 2. 25n, excuse me. Which means that he can multiply in. Which gives me 25 over 2 plus 25 over 2n. And at this point, I'm not plugging in numbers because I'm going to take the limit of this. And when I take the limit as x approaches infinity, it's like saying I throw in the infinity in here. And when I do that, what happens to this term? It's like saying it goes to 0. So my answer here is just 25 over 2. Also, just like when we did with our integration, sometimes we have to simplify before we can find it. It makes no sense to try and plug all the different pieces in because I'm still going to have to take it out. So let's go ahead and multiply. So 2 times 2 is 4, and times n is n squared. So I'm going to take the limit of this summation. So I'm going to go ahead and take out my n squared. That leaves me with 4i. Which means that n squared is equal to 4 times n plus 1 divided by 2. Again, no constants to add. So I have 1 over n squared. 4 and 2 cancel, which means I'm going to just multiply through a 2. So I have 2n squared plus 2n. We're going to go ahead and divide by n squared. That gives me 2 plus 2 over n. And again, since I'm taking the limit of this, my answer here is just 2. That's all I got for you. See you tomorrow, guys.